We are here to help.
There are two ways to check if a first-order nonlinear differential equation is homogeneous. If we arrange the equation in standard form, we can determine if the functions m and n are homogeneous by checking whether the following two equations are true, where a is a constant. Or we can rearrange our differential equation for dy over dx and check to see if we can rewrite the right-hand side as a function of y over x. Once we know our differential equation is homogeneous, we can solve by making a simple substitution. Let's look at an example. Since this differential equation is already in standard form, we can check that m and n are homogeneous functions. We evaluate m at ax and ay, and check to see if we can factor a power of a out. Since our result is a to the power of 2 times the original function m is homogeneous. We do the same thing with n. Since we get a squared times the original function n is homogeneous. We will also show that if we isolate for dy over dx, then we can rearrange the right-hand side as a function of y over x. To solve the equation, we make a substitution y equals ux, where u is a function of x. We will also need the derivative of y, so we can transform our equation in terms of u and x. When we have y and dy, we can substitute these into our original differential equation and simplify. We will leave this simplification to the viewer to check. Once our equation is simplified, we need to make sure our variables are separated on either side of the equal sign, since we will always end up with a separable differential equation in u and x after simplifying. When we integrate both sides, we get u to the power of 2 over 2 equals ln of x plus c. Now we can substitute back in terms of y by rearranging y equals ux to substitute for u. Before we do some more rearranging for y, we will replace our constant of integration c with ln of c. We do this to make it easier to simplify the right-hand side using logarithm rules. Since ln of c is also a constant, this will not affect our solution. Now we can use logarithm rules to combine the two terms on the right-hand side. We will multiply by 2x to the power of 2 on both sides so everything is isolated for y. And we have our solution. Now we can plot a few solution curves.